And why is that already? You have a...
Ik ben in Nederland opgegroeid, maar ik was bij een internationale school toen ik heel klein was. En ik was hier van mijn 10e tot mijn 18e, maar ik kom eigenlijk uit Amerika. Ik ben best wel mixed up. Ik heb in 9 landen gewoond. Dus.
Okay, so 9 languages, right?
Something like this.
Nou, het leuke is dat Fabiola wil iets vertellen over onderzoek, wat ze nog wil gaan doen. We hebben het ingediend bij de Hersenstichting. En past eigenlijk perfect. We hadden ook van tevoren nagevraagd, is dit een goed idee? En ze waren zeer enthousiast. En uiteindelijk is het afgewezen. Maar we weten helemaal niet goed waarom. Ze hebben nauwelijks enige reden gegeven. Maar Fabiola is zelf iemand die dan doorpakt. Ze heeft het ook bijna zelf geschreven, met mij een beetje op de achtergrond. Ze is een van ons nu, want ze heeft ook een klein beetje geld afgekregen om te starten. Nee, perhaps you can tell yourself that and I do.
Sure. Can I tell it in English?
Yeah, do it.
Thank you. I feel more comfortable. So, as Eric said, we were very frustrated. Actually, it's a longer story than that. I lost my PhD position very last minute at the University of Oxford. I had the PhD position from January until August, and then because of Brexit and funding issues and supervisor issues, I lost it, so I didn't have a place. And Eric generously gave me a place, but said I unfortunately don't have money for you right now. So here I am, pushing forward with my project, and what I came up with was the idea that actually I have a product. I don't just have a research, I have a product. So I thought that if I created a startup company as a spin-off from my research, that I might be able to fund my project independently. And that seemed to be successful. I acquired a loan for myself, and investors managed to match the loan. So now we move forward with the research, thankfully speaking, after about 10 months of preparation, trying to get it to this point.
Yeah, so it was a very difficult
It was a journey
but you're here
so far, but I am here.
And you
I'm
did
really
your
glad
research
to be
master
here.
at our department. So
I
you
did.
did the research master cognitive neuropsychology with us here. So that's where we became acquainted.
Yes.
From this point on, we
Yes.
will work together.
But you're also working on your PhD.
I'm
already.
doing my PhD
Right.
with Eric, yes.
You're starting up with this project.
All right, great.
So now we will start officially.
Now.
Yeah, we've been in the preparation phase for quite some time, and now we will officially go forward with the research phase. So, may I start my presentation?
Yeah, start up, right.
All right. So my
Colors
product.
were good just before, huh?
Excuse me?
The colors of the
They were blue before, and now it seems like they're green. The light here is projecting green. We can't. Not sure
Het
what
is,
we can
die
do
lamp is
to-
niet in orde gewoon.
Oh, het is bij alle praatjes.
Ja.
Nee, dat weet ik niet, maar dit
Je
deugt
ziet
niet.
die lamp groen als je er hierin kijkt.
Ja, maar
Well, it looks mysterious, let's say that. Yeah.
It gives a kind of an eerie feeling. We're heading into autumn, so
Yeah.
early for Halloween. All right, so again, I'm Fabiola Brugger-Dadis, and my research is surrounding virtual reality and rehabilitation of cognitive deficits in stroke patients. So as we know, on a global scale, stroke is a very large problem right now, and it causes a great deal of disability and lack of independence in people who experience a stroke. In the Netherlands alone, we have about 46,000 strokes each year, which is astoundingly 125 per day. And there are over 175,000 people currently living with the consequences of having experienced a stroke. So what happens is, because part of the brain is impacted during a stroke, often we will experience, or we will see the patients experience motor deficits and cognitive impairment. Mostly the cognitive impairment, it can be a variety of factors, but the general factors that we most frequently observe are attention deficits, memory, visuospatial executive function, and language difficulties. So what do we do to help these individuals who have experienced something so devastating as a stroke, and they need to move on with their lives, they need to live a normal life? Well, rehabilitation is an important part of both the first, acute phase, let's say the first 6 months after a stroke, and also the chronic phase, the 6 months following that. This typically consists of a lot of rehabilitation, and it's very arduous for patients. They find it very difficult. They find it time-consuming. It's time-consuming for the doctors. It's time-consuming for the people that are having to go to a rehabilitation facility on a regular basis in order to do this and accomplish this. And generally speaking, they find that it's quite boring. They are doing a lot of these repetitive tasks over and over again to try and stimulate reorganization and rewiring of our cortex, because as we know, research has demonstrated that this type of rehabilitation can indeed contribute to facilitating neuroplasticity. However, there's a lot of limitations, as I briefly explained. It is time consuming, it's costly, it's labor and resource intensive. There are modest effects, meaning that a lot of the time the patients don't really appreciate it. They're reminded while they're doing rehabilitation that they have a cognitive deficit or a motor deficit. So it's not very fun to be reminded and challenged constantly that you have this major problem. In a survey of 799 chronic stroke patients, what they found was that while motor rehabilitation is often focused on post-stroke, what you don't find is that cognitive deficits are often addressed post-stroke rehabilitation. And the caregivers that were also interviewed in this survey suggested that investigating ways to improve cognition should really be a priority in research moving forward, and that there's a need for more accessible cognitive rehabilitation tools in order to accomplish this. So what is the solution that I came up with? Well, we're moving into the future, and so VR is the way of the future. And what I thought to myself is, how can we have patients who are sitting around doing nothing for such a long amount of time in the rehabilitation facilities or nursing homes in their chronic stage? How can we have them be active and doing something that could potentially contribute to their cognitive well-being and their overall ability to perform activities of daily life moving forward in their lives, So I came up with this virtual reality. The advantages of virtual reality is that because we're now in a society where in the beginning, smartphones were extremely expensive, but then they become cheaper and everyone has them. Similar thing with virtual reality. In the beginning, it's quite expensive and it's not accessible, but now someone could buy a Google Cardboard headset for about 10 euros, and that's compatible with most smartphones. So you can run a different cognitive training app on this Google Cardboard headset, and in that way, patients can utilize this not only in a rehabilitation or clinical setting, but also when they're discharged. What I also thought was really nice about virtual reality is that we create a gamified program here. As I mentioned, patients are generally finding that rehabilitation is quite boring. So if you get them to play games, then we've seen in other types of research that this improves adherence, it improves motivation, and it really gains their attention in a different way than if they're just standing there and having to be reminded frequently that they have these deficits. So there has been quite a few studies that have shown that VR is definitely effective with stroke patients. However, these studies have been very much limited to the motor function domain. And these are based on 3 neurobiological principles. Neuroplasticity, the mirror neuron system, because with VR, so that first of all, with neuroplasticity, with VR, you are repetitively achieving goal-oriented task training. So we are trying to train a specific task, and in the VR, you can use it for a long time, and it's going to be targeted towards a specific deficit, each of the tasks. The mirror neuron system and the brain reward system. I'll further explain how this ties into my particular intervention later on. Because of the lack of research in the cognitive domain and the few methodologically weak studies that exist currently, they had very, very small sample sizes, and the fact that the functional neural networks that are responsible for motor processes are the same as those responsible for cognitive processes, we hope that this neurobiological rationale will hold true for rehabilitation in the cognitive domain also. So moving forward with my particular study and the current study, is cognitive rehabilitation with VR more effective than conventional cognitive rehabilitation? And we want to investigate different facets of that. For example, can we improve cognitive function with VR? And if so, to what extent is this more valuable than traditional means of cognitive rehabilitation? Are we able to achieve higher patient adherence? Are we able to investigate some of these assumed advantages, such as the fact that maybe with VR, because people are apt to use these programs longer and more intensively, you might have shorter periods of training needed to see results for benefits in cognition. We also want to see if maybe there is an indirect improvement on motor function, because some motor skills require cognitive functioning in order to take place, such as planning. And where data is available, if there's patients, for example, who are involved in other studies where they have MRI or CT scans available, we would love to see pre and post intervention if there are any neurobiological effects of the VR intervention. So we are ambitiously going to test a large cohort of 100 stroke patients with a confirmed diagnosis 6 months post-stroke, so chronic population. A few reasons for this: generally tend to experience a little bit of motion sickness when you're going through this type of a VR setting, and what the experience is with the acute phase is oftentimes that's a little bit much for them. They get too nauseous, and they don't find that right now with the VR, it will move forward in the future into a way that we can have immersive VR that is good for acute phase, but currently in the acute phase, they're utilizing bulky, similar to like Nintendo Wii type setups where you'd have a green screen and the tracking would be done, but this is not portable. This can't be done at home. And the whole point is that we want to continue rehabilitation as much as possible. So we'll randomly assign our participants to either a VR group or a control group that receives traditional cognitive rehabilitation, and the participants will be blind as to what condition they're in. I haven't figured out if there's a way to double blind the study, because I don't think that if someone is giving the VR intervention, then they know that they're giving the VR intervention. It will be difficult, but maybe we can figure something like this out with the research assistant. So we will give informed consent and baseline assessments of cognitive and motor function. In the VR group, they will receive training on how to use the VR intervention. And then they will, consistent with prior research, receive 4 weeks of 30-minute rehabilitation sessions 5 times per week. The control group will go through a typical standardized program of cognitive rehabilitation training. We will do a follow-up assessment at 2 weeks' time, and then the final assessment and a semi-structured interview to reflect what their thoughts and feelings were about this particular intervention after 4 weeks of treatment. So in order to do this, we'll use some standardized neuropsychological tests from the WACE and translated into Dutch for use with Dutch participants, and other tests that are suitable for use with Dutch participants. And specifically, again, we're looking at language, visuospatial skills, memory, executive function, and attention. Secondary measures would be testing motor function, and then again, in a subset, if it's possible, addressing the neurobiological changes, and then subjective outcomes at the end via a semi-structured interview. So now getting into the more exciting part, my intervention. So the VR intervention will be provided via an HMD, so a fully immersive headset, not, as I was describing to you, something like a green screen that's less immersive. The exercise is going to be designed with Unity game engine, and each of the games, so there'll be separate games, will train a specific cognitive function. This is, as I explained, what I hope to contribute to the ability of the brain to reorganize and rewire following this injury, is this goal-oriented, task-oriented, directed training based upon typical types of rehabilitation, but then made into a gamified program, making it more fun. The participants will have the ability to view correct examples of the task prior to beginning, and they'll also receive feedback during their task. So hopefully enabling them to engage their mirror neuron system and have successful practice and learning of these tasks. And finally, the level of difficulty will be increased gradually, and with every let's say level that the participant is able to go up, then they'll receive awards or achievements for this in order to activate the reward system, because this has been found in gamification to be something that's quite an important factor. So let me give you an example of a game. So what the greatest thing in my opinion about VR is that you can do this whole bucket list checking off. You have all of these elderly patients who maybe didn't get to experience a lot of things in their life that they wanted to. Now they've had a stroke, so what do? Well, say you want to be an astronaut and you want to travel in outer space. VR can allow you to do that. So for the attention game, they're going to be developed a little bit further as I'm getting more progressed with my research. I want participants to imagine that they're an astronaut in outer space and they're going to be surrounded by planets and stars. And then they will be asked to select, for example, only the planets with a ring. What ideally I would also like to do is, you see how there's a gap on the side here of this ring? A lot of the time, because of visual neglect with stroke patients, I want to also be able to take into account if they are having or experiencing any type of visual neglect, that this can also be accounted for in these types of tasks. So hence, select the planets only with the ring, and maybe only with the ring with the partition in it, or something of this nature, so that we can take this into account. And then increasing levels of difficulty, we will have either more targets or more distractors as moving forward. We will use repeated measures ANOVAs and t-tests in order to observe differences pre and post intervention and between the different groups. And we hope that the VR rehabilitation will indeed improve cognitive functioning, and that it will indeed improve cognitive functioning and surpass that improvement as seen by means of traditional or conventional means of cognitive rehabilitation. We also hope to see higher patient adherence, shorter periods of time needed for this improvement, also indirect benefit for motor function, and, if possible, structural and functional changes in the brain. I have a provisional work plan of going through the development of the games, the ethical approval, patient recruitment, and then ambitiously testing my 100 patients, giving preliminary results in the meantime, and finally, after the collection of data, doing all of our analyses and figuring out what we've got here. Publishable results expected after 36 months. And I am collaborating with a really cool group here. I have Eric Skerder, who you guys all know is my supervisor and the primary investigator. I'm very excited that he's part of this project. He's been very supportive of this whole endeavor from the beginning. Dr. Thilo Hartmann, who is a professor here at FU in the Communication Science Division, and he is heading up the virtual reality group at Amsterdam Applied Gaming Research Community. He's going to help advise me on media psychological issues such as cyber sickness. As I was explaining, a lot of the time patients get really dizzy, and so we want to make sure that the usability is friendly for a patient population. We want to make sure that the user interface is friendly for a patient population, that they have a really positive psychological feeling after they leave this type of a game instead of feeling taxed or tired. In terms of advising on gamification, this is Marciano Leon. And do you guys all know the game Candy Crush from Facebook? He is the main producer for Candy Crush. So he has jumped on board as my COO of my startup company, and he's advising on all aspects of gamification. And then I needed someone to help me with 3D design. So I have here Dmitry Jurkin, we call him Dima. And Dima is a master's student at SCAD in the United States, and he has 7 years experience in 3D design and animation professionally, as well as currently being a master's student. So because SCAD is a big university in America with regards to virtual reality innovation and these types of technological innovations, I had him come on board to also bring to the table the resources that SCAD can help us with. And in conclusion, we hope that because of this high prevalence of strokes that is experienced and the need for accessible tools for cognitive rehabilitation, that we can create some type of really nice solution with bringing an exciting and new tool to the table that can be utilized by patients and clinicians in order to improve cognitive function. That's it. Thank you guys.